na nandito ang ating Q3, no, nandito mas malayo pa. Tapos nandito ang ating median. Tapos same ang ating Q1, no, ganyan. Then same value of max and min. Ganito ang magiging boxplot natin. And kapag ganyan, ito yung right skewed na, obvious na talaga siya, right skewed na siya. Ito, pag ganyan ang itsura niya. O kung gusto mo, taasan mo pa. Walang problema doon dahil dito ang perspective lang is x-axis. Ayan. Alright, good day everyone. Welcome to our next topic. And for this presentation, we will be discussing all about an outlier. So, outliers, by definition, an outlier is actually an observation point that is distant from other observations, or an observation that lies outside the overall pattern of a distribution. So, for example, we have a group of data. Then there is a certain data, no, 2, 3, or 4 data that is very far from the general data, or they are very distant from the other data, which is they basically lies outside the pattern overall, no? So kumbaga sa inyong mga classmate, ito yung lahat masaya na tapos siya nasa isang gilid lang, no? Those are outlier. I hope you get it. Now we have actually a data set should be checked for extremely low and high values called outliers. So, as it indicate experimental error, thus sometimes excluded from the dataset. One thing for the reasons why we should study the outlier, because we should first, on the data cleaning part, no, we should first know what are the outliers of our dataset, if there is, and we should now exclude them, no, from the dataset, because actually when we include outliers in our computation, there is a huge possibility, or there is a huge chance that there will be some errors in our analysis, on our further analysis and discussions for the computation, no. So let's have now the method in determining different types of outlier. Actually, we can determine an outlier in both mild outlier method. This is the first one on the top part of our presentation. And the second one, the extreme outlier. Now, for the mild outlier method, the formula is Q1 minus 1.5 multiplied to our IQR, or the interquartile range. If you are still not familiar with our quartiles and interquartile range, you can watch again our presentation for this topic, no, our previous presentation for this topic. If a specific data is actually less than the value of this formula, whatever number we can get from this formula, it is called an outlier, a mild outlier. Now, and also the same goes with the greater value that we got from this formula, which is the Q3, or the third quartile, plus 1.5 multiplied to the interquartile range. And if the specific value that we can get from this formula is actually greater, no, greater than this formula, that is also a mild outlier. I hope you get it. Same goes with the method of determining an extreme outlier. If the data that we get from these two formula is less than or greater than the value of these two formula, it is what we call the extreme outlier. The only difference, guys, is that on the mild outlier, the coefficient is 1.5. For the extreme outlier, the coefficient is 3. No, that's the only difference. I hope you get it. So let's have our example for determining an outlier. Okay, example. Check the data set of the ages of 9 middle management employees of a certain company and look for outliers. So we are talking here all about their ages. I hope you can still remember this problem. If you are not familiar with this problem, you can check out our previous presentation about this problem. So for this presentation, we will not be solving the quartiles because it is actually given based on our previous problem. No, na-solve na natin ito before. So, sana naalala nyo pa, ang value ng quartile 1 niya is actually 47. Kasi kapag sinolve pa natin, it will be very tedious on our part. We will begin on the first step. Kaya nga lagi kong sinasabi, no, ang statistics, dugtong-dugtong yan. Kapag umpisa pa lang, medyo nalito ka na, dapat mong klaruhin yung part na yun. Kasi kapag nag-proceed ka na hindi mo nakaklaro yung part na yun, may iwan ka. Malilito ka talaga hanggang sa mga next, no? Hanggang sa dulo, sa mga next na ating topics. Okay? So, for the quartile 1, we have 47 here. For the quartile 3, actually, the quartile 3 of this data set is 56.5. Ayan, 56.5. And, for the IQR, just like what we have solved before, IQR is, again, the formula for this IQR is Q3 minus Q1. So, basically, you'll just get the difference of these two numbers. 56.5 minus 47, that is actually 9.5. Alright, so let's have a test for mild outlier. Mild outlier test. Okay? Alright. Let's have our formula. Again, less than or greater than Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR. So, let's have first the less than. Q1 minus 1.5 IQR equals, let's have our values here. For the Q1, 47 minus 1.5 multiplied to our value of the IQR, which is 9.5. Okay, so no problem for this data. You can direct this to your calculator. 47 minus 1.5 multiplied to 9.5. This will be 47 minus the product of these two, 14.25. As a summary, this is 32.75. Now, let's move on to our next mild outlier test. Sa upper part naman, let's have Q3 plus 1.5 IQR. This is I. Yan. Okay. Now, for the Q3, now we have 56.5. So, substitute natin. 56.5 here. Minus, plus 1.5. No? So, 1.5 multiplied to our IQR, which is 9.5. Okay. So, this will be 56.5 plus 1.5 multiplied to our value of the IQR na 9.5, that is 14.25, and this will be now 14.25 plus 56.5, that is actually 70.75. Alright, now let's check the data set for any data values that fall outside the interval from 32.5 to 70.75. How was it done? No? As you can see, the minimum number of our dataset is 45. Let's check if there is still lower than 45. 54, none. No? So, this is the lowest number or the minimum number. The max number, the maximum, the highest number, 59... 58. Okay, so that is 59. Meaning, this is their range. No, sorry, 59. This is 59. Okay, this is their range, guys. Now, let's check now if there is a number, specific part of the data set that goes below 32.75. So, let's assume this is the place where 32.75 is. And this is where the 70.75 is. Let's check if there is some data that falls outside these two barriers or these two limits, no? These two outliers. And as you can see, 45 is our minimum, meaning to say it is still between 32.75 and 70.75. And our maximum is 59, meaning, again, it is between 70.75 and 32.75. Therefore, there is no outlier for this data. I hope you get it, guys. Now, if it happens to be, there is a data in our data set which is, the value is 75. So, definitely, 75 is placed here. Now, so meaning to say, if there is 75 here, and considering there will be no changes in the computation, but I know there will be, no, because an additional data can affect the values of Q1, Q3, IQR. So, 75 here, meaning if there is 75 here as an additional data, that can be now considered as our outlier. But since, again, for the mild outlier test only, there is no outlier. No, I hope you get it. Now, let's proceed with the extreme outlier test. Okay, for extreme outlier test, let's have here the title first. Extreme outlier test. Okay, so let's compute the lower limit. That will be Q1 minus 3 multiplied to IQR. Now, I am right. Here, this is the formula for extreme outlier test. Q1 minus 3 times IQR. And same goes with the upper part of the limit, which is Q3 plus 3 multiplied to IQR. The only difference is the symbol. No, the mathematical operation. So, let's have here. Yan, and the other one, plus 3 multiplied to our IQR. Okay? Okay, for the Q1, again, our Q1 is 47, our Q3 is 56.5. Sorry. For the formula, rather, guys, this is Q3. No, that is still the second difference. This must be Q sub 3, okay? For Q1, again, we have 47. So, let's substitute 47 here. Minus 3 multiplied to our IQR, which is 9.5. So, 9.5. Okay, so this will be 47 minus, I hope you have your calculator with you so that you can have your computations with me. No, 3 times 9.5. This is a 28.5. Okay, and 47 minus 28.5 is actually, the value is 18.5. Okay, now let's proceed with this upper limit of our extreme outlier test. For the value of Q3, we have 56.5 here. So let's have 56.5 plus 3 multiplied to our IQR, which is, let's direct input it. No, I will delete this one. Let's direct the 9.5. Okay, 9.5. Okay. Now, 56.5 plus the product of these two, which is 28.5. 56.5 plus 28.5, that is actually 85. Now, same goes with the mild outlier test, assuming that this is our minimum value and our maximum value is 59. Where is 18.5? Therefore, 18.5 is around here. No, 18.5. And where is 85? Around here. This is 85. Meaning to say, if the data set is between this lower and upper limit of our extreme outlier test, therefore, there is no outlier. Now, I hope you get it. So, as you can see, our outlier test values is actually has a range of greater range compared to our mild outlier test. For the mild outlier, as you can see, we only have 32.75, and actually this is the place where 32.75 is, and 70.75. Ayan, 70.75. So, this is our data set, right? Ayan, 45 to 59. And this one is actually our mild outlier test. And this one here, ayan, is our extreme outlier test. So as you can see, the extreme outlier test again has higher value of range. So meaning to say, since our data set is inside our range for outlier test, there's no outlier for this data set, no? So answer, no outliers. I hope you get the idea, guys, no? Now, let's proceed with the box plot or the Box-and-Whiskers plot. As you can see, by definition, the Boxplot is actually introduced by John Wilder Tukey in 1970s. So, it says here that if the median is near the center of the box, the distribution is approximately symmetric. Now, if you can still recall, median is equals to the value of the quartile 2, and it is at the center, of course, of the distribution. And if it is also the center of the box or near the center of the box, approximately our data set distribution is symmetric. Now, if the median falls to the right of the center of the box, the distribution is negatively skewed. I hope you are now familiar with skewness. If not yet, you can learn it again from our previous presentations. And the other way around, if the median falls to the left of the center of the box, the distribution will now be a positively skewed distribution. Now, so for the steps on having our box plot, first step is actually to determine the Q1, the median, and the Q2. This is the reason, guys, why the topics on the quartiles, deciles, and percentiles are discussed first before the box plot. No, I hope you get it. Second step is to locate the lowest value and the highest value in the scale for our range, of course, and also for our weak part of the box plot. And third step is to draw the box around Q1 and Q3. So, drawing a vertical line, draw a vertical line through the median and connect the upper and lower values. So, if you don't get it for our textual steps, we can now do it visually, no, para mas malaman ninyo. So, for the Box-and-Whisker plot, a graphical summary of data using 5-number summary, which are the minimum value or the lowest value of our dataset, the quartile 1, the median value, also the quartile 2 of our dataset, and the Q3, and of course the maximum value or the highest value of our dataset. As you can see, this is how the box plot looks like. Now, the minimum value here on this part, maximum value here, and for the first quartile and third quartile range, we should draw a box. No, that's why it is called box plot. And let's label their median or the value of the Q2. This is how the box plot looks like. Now, if the box plot or if the value of our median is exactly at the center, no, like this one, it says here that the box and central line are centered between the endpoints if data are symmetric. If they are symmetric, 50% on the right, 50% on the left, around the mean. A Box-and-Whisker plot can be shown in either vertical or horizontal format. So this one is a horizontal format. You can show this on a vertical perspective. No, so if this is the box plot, if this is how your box plot looks like, this is more likely normal distribution. And if it's not symmetric, guys, this is the counterpart on the graph. If your median is around here, no, so more likely the shape of your distribution is going to the right skewed distribution, no, or positively skewed distribution. Vice versa with this one, left skewed distribution, no, going to the left siya if nandito yung Q2 mo. Ayun yung difference nila. I hope na nakuha ninyo, no? So, meaning to say, kahit pa ganyan yung distribution mo, since we are talking with quartiles here and if you still remember, when we say quartile, we are dividing the whole data set into 4. No, meaning to say, kahit pa maliit ito, tas ito malapad siya, together with this one, malapad sila, still, yung value nito is 25% of our data set. And yung value nito is still 25% of our data set, kung ano man yan. And ito, 25% of our data set. And ito is still 25% of our dataset. No? It all depends with the frequencies. That's why our first topic is all about frequency distribution. And for the frequency, it is actually the y-axis here. No, this frequency. As you can see, since the upper part of our distribution is here, no, around here, doon marami yung data. No, doon mas maraming data kaya nagkukumpulan sila dito. No, nandoon yung pinakamarami kasi yung frequency natin. No, I hope you get it. The other way around for the right skew distribution, no? For the symmetric, pantay sila 50-50. I hope na appreciate niyo. That's the reason kung bakit ko nasabi na si Boxplot is the summary of descriptive statistics for me, na personally, and of course, statistically speaking, it is the summary of descriptive statistics per data. So let's have an example here. Check the data set of the ages of 9 middle management employees of a certain company and construct a box plot. So the ages are 53, 45, 59, 48, 54, 46, 51, 58, and 55. I know you are already familiar here. Kakagamit lang nito sa before na topic natin, which is the outlier. No? So, given na ang ating data, which is ito, nilagay ko na siya, 9. Lowest value is 45. This is the 45. Highest value, we have here 59. So, for the median or the value of our Q2, this is 53. Q1 and Q3, also, nagamit natin to sa ating outlier test. No? Ito rin yung values nun. Let's have now our box plot. So, first, no, ito personal ko ng technique. Para magawa nyo ng pantay yung box plot nyo, gawa lang kayo ng x-axis. Then, tignan nyo ano yung lowest value, 45. Ano yung highest value, 59. Ibig sabihin, pwede kang mag-start dito at 45. Pwede kang mag-start ng 45 by 5. No? Skip counting by 5. Pwedeng 45, 50, 55, 60. Nakuha nyo? 4. Pwede yon. So, i-divide natin ito into 4. Ayan. Again, x-axis lang. 45. Then, next, we have 50. For the ano lang, no, para pantay-pantay sila. 55 and 60. Now, the minimum value is 45. So, let's have here 45. For the minimum and maximum value, guys, ang gagawin nyo is straight line, vertical, no? If horizontal yung box plot niyo. Horizontal naman for the lowest and highest value if ang box plot niyo is vertical, no, patayo. Kasi nga, nasasabi kanina, we can show the box plot either vertical or horizontal format, no? So, next, ang highest value natin is 59. So, if this is 60, medyo ano ng konti, no? Dito ng konti. So, let's have here the value na 59. Ayan. And next, our Q1, 47. So, since this is 45, more likely ito ang ating Q1. Ito yung ating 48. Dito banda ang 47. Ayan. Next, 56.5. Nasaan si 56.5? Banda dito. No, yan, lagay tayo dito, 56.5. Okay, then let's connect this Q1 and Q3, no? Let's have a box here. Oops. Muntik na namang dumiretso. Burahin natin para maganda siya. Okay. So, let's have here a horizontal line that connects Q1 and Q3. Ayan. Then, let's connect this, guys, yung center nila. Ayan. And, ito. Our median, no, 53 daw. So, malamang nandito siya. Or, ikanan natin ng konti dahil ano siya center siya ng 50 and 55. So let's write here our median around here. Ayan. So kung nakapapansin nyo na medyo mas malapad compare dito sa week na yan. Week ang tawag dito. Meaning to say our data is somehow right skewed. Somehow right skewed, no? Kung gagawa natin ng graph, ito, ganito ang itsura niya. Somehow right skewed siya. Dapat. Ito yung tuktok, no? Dandyan yan. Tapos, ito, pababa na ng pababa hanggang dito. Somehow right skewed. It looks like a normal distribution, pero somehow right skewed siya. Since we are having a higher range dito compared dito. No? Parang ganito ang itsura niya. Ito. Yan. No, na hindi ganun ka-obvious, no, dito natin makikita. Pero if ever na nandito ang ating gawin ko ibang kulay, if ever na nandito ang ating Q3, no, nandito mas malayo pa. Tapos nandito ang ating median. Tapos same ang ating Q1, no, ganyan. Then same value of max and min. Ganito ang magiging boxplot natin. And kapag ganyan, ito yung right skewed na, obvious na talaga siya, right skewed na siya. Ito, pag ganyan ang itsura niya. O kung gusto mo, taasan mo pa. Walang problema doon dahil dito ang perspective lang is x-axis. Ayan. Ayan, pa-right skewed talaga siya. Now, I hope you get it, guys. That ends up our discussion for this topic. Outlier and the boxplot, box or whisker plot. And thank you for your time. Thank you for your participation and keep safe always. See you on our next discussion. Bye-bye.